So making a drone is so easy if you have money, right? But let's break this myth today. Welcome to this One Ideas. I'm starting an exciting video series about building a drone on a budget using our favorite Arduino boards. In this first part of video, we create a custom 6-channel transmitter and receiver perfect for controlling drones, robots, or even RC cars. This DIY transmitter and receiver setup comparable to a commercial FlySky system, but way more budget friendly. And in the next video, we use this setup to build our very own Arduino powered drone. So let's get started. Here is everything you need to build a transmitter and receiver communication setup and eventually the drone. For this video, we focusing on this part. And these additional components will come into play in the next video when we assemble the drone itself. But for now, let's start by building transmitter. We start with 0 PCB and 2 joystick modules. One module will control throttle and yaw, while other handles roll and pitch movement. Let's quickly place all the components on the 0 PCB.
Tacklers are cooking in the lab. Rizwan's got the gadgets, never drab. Arduino flow circuit board slap. Raspberry Pi magic, never a gap. Wires tangled, but his mind's clear. DIY genius, no fear. Printing dreams in 3D layers. Sensors beeping, tech so rare. Rizwan's ideas, sparking light. Building futures every night.
Here is the connection diagram we follow. It's simple and straightforward. So now let's solder everything together. All the connections are complete. The front side looks very clean and professional, but the back side, well, it's a mess of wire. Not very professional looking, but don't worry, I have a solution. Thanks for today's sponsor LTM365 and LTM Student Lab. It is an incredible platform for inspiring electronics designers. With LTM Student Lab, you can get free access to 2 powerful tools. LTM Designer, a world-class PCB design software that's professional used to create advanced circuits and systems. And LTM365, cloud-based collaboration tool that lets you teach your designs and work with your team, no matter where you are. This is fantastic opportunity to learn how to design PCBs like a pro while earning certificates recognized by leading industries in India. It doesn't stop there. LTM Student Lab provide PCB design courses. They are structured university level courses that teach you A to Z of electronics designs, certifications and advanced tools. You can get free access to tools like a power analyzer by Keyslide, helping your design and test circuits even the greater precision. I personally use LTM Designer to create professional grade PCBs like this one, and I showcase this next part of the video. It is user friendly, packed with advanced features and make turn your ideas into reality so much easier. So if you are serious about learning PCB design and standing out in the industry, head to the link in the description to get started with LTM Student Lab. After I design the PCB, I will order it from nextpcb.com, and in the next video, we will use these professional design PCBs for our drone project. Now let's get to the build. Let's move on to the programming transmitter. For this, you will need NRF24 library. The codes are available in the video description. Select the Arduino Nano board, upload the code, and we good to go. Look at that. The OLED display is working perfectly and the transmitter part is ready. Let's move on to building the receiver. For receiver, you will need other Arduino Nano NRF24 module, a 3.3V adapter and few buck strips. The NRF24 modules operates at 3.3V. To safely connect them to Arduino Nano which use 5V. So I am using this NRF24 adapter board. They not only regulate the voltage but also ensure the stable operation. Using this circuit diagram, we connect everything together. You can find the diagram in the video description or my website at rizwansideas.com. Now the receiver is ready and the pinouts is same as a commercial transmitter. First one is roll, pitch, throttle, yaw, auxiliary 1 and auxiliary 2. Now let's program the receiver. Here you can see I add failsafe mode, which is gradually reduce the throttle if the drone goes out of the range. This ensures the smooth landing and avoid crashes. Upload the code and now our receiver is ready. But wait, it is not working yet. To troubleshoot, I add 100 UF capacitor between the NRF, VCC and ground pin. This reduces noise and improves stability. Now it's work, but there is still noticeable delay, which makes unsuitable for flying drone. The problem lies with the OLED display. The Arduino Nano's 8-bit AVR microcontroller struggle to process both OLED and NRF tasks in real time. So I disconnect the OLED and reprogram the Arduino, but don't worry, the final code is available in the description. And now it is working perfectly, super responsive and ready for action. I also made a 3D printed case for transmitter. If you are interested to building like this one, you can download the 3D files from my website thisonesideas.com. It is a great way to make your projects look professional. That's it for this part of video. In the next part, we use this custom transmitter and receiver to build a fully functional Arduino powered drone on a budget. So make sure to subscribe, hit the bell icon so you never miss when I upload the part 2. And like this video to support our channel. Thanks again LTM365 for sponsoring this video. And I see you in the next one.
Tech tips hitting just right. Real ones, ideas, spark and light. Building futures every night. PCB dreams take to flight. Tech tips hitting just right.